Hello guys, let's practice while loop using these three programs. What we'll do is we'll try to write these three programs, and while writing these three programs, all these three programs basically involves the use of a loop, and we'll try to see how we can use while loop specifically to write these three programs. Let's see the first program. Okay, what this program is asking you to do is write a program to print all multiples of 3 between a given pair of numbers. So for example, the given pair of numbers are from 0 to say 10. Okay, what you have to do is, what your program has to do is, it has to print all the multiples of 3 within this given range, including 0 and 10. Okay, so what it will do is, okay, what will be the output in that case if the range is given as 0 and 10 and we are looking for multiples of 3? Then the output should be 0, then 3, then 6 and 9. Okay, the next one is your 12, but it is greater than 10, so we are done. So this should be the output if these are the inputs. Now say another range, you just consider, say for example 4 to say 18. So in that case, the output should be 4, not 4 certainly. The output should be not 4, not 5. It should start at 6, then not 7, not 8, 9, then not 10, not 11, that is 12, then 13, 14, no, it is 15, 16, 17, no, and there is this 18. Okay, then 19 certainly we do not have to check for because it is outside the range of this 4 and 18. Now see why I have given these two example is, see here the first number is coming in the output. Here in this case, if the range is given as from 4 to 18, where the first number is not divisible by 3, in that case certainly it is not coming in the output. Okay, that's just to give you the what sort of, I wanted you people to look at that point. Okay, because see here sometimes what happens is, okay, once we this is only one probable input and this is the output, so directly one impression might come into your mind, okay, whatever the first number is, that always comes in the output sequence. Okay, but that is not the case actually. If you consider, if you look at some other example, you'll see that it is not always the case. The case is only when, so what we are doing in general, say for example, no matter whether the input pairs are given range is from 0 to 10 or 4 to 11 or 4 to 18 or whatever it is, what is the general thing that we are doing? If we see that, let's see here what we are doing within a given range of numbers. Say for example, starting number as anything, say for example from I, the next number is I plus 1, then the next number I plus 2. This is the sequence or the range of numbers that we are checking, and say last one is your I plus k. So where our given sequence is I, and like the given range is I and I plus k. So if the first number is I, and it means this is the range given, so it means the first number is I and the last number is I plus k. So we are writing it in this way. Then what we are doing is, we are going through each and every number and checking if that number is a multiple of 3 or not. If it is a multiple of 3, then we are printing the number, and if it is not a multiple of 3, we are not printing the number. So again, if for example you consider this sequence from 4 to 18. So if we have to print all the multiples of 3 within the range of 4 and 18, what we do is, first we just consider, okay, the number line. We assume that there is a number line that starts at the given first number and that ends at not the last number. Say for example 4 to 18, it means what? 4, 5, 6, 7, 8, like that. What we have to do is, we have to iterate over all these numbers one at a time, and we have to check if that current number is a multiple of 3 or not. What I mean is, say for example, how do we iterate over all these numbers? So we can make it use of a temporary variable, say for example x. In the first, see here we are now talking about a loop. When the control, or when you execute the loop for the first time, you want this x to point to, say, the first number. Okay, then you want, in the next iteration you want this x to point to the next number. In the next iteration you want to point this x to the next number, and like that. In the last iteration you want this point x to point to the last number. Okay, so we know how to do that using a loop. Again, if you are not sure how to do it using a loop, then we'll, very shortly you are going to see how to write the program. But for the time being, what is the what like in a in a conceptual way, what we're doing is we want to iterate over all the numbers one at a time within the given range. Okay, that is the starting and the ending. Okay, so for example, if the range is 4 and 18, in that case we want to iterate over all the numbers, means all the integer numbers within the range of 4 and 18. Okay, and then we want to iterate in the sense that first we'll assume that, okay, there is a temporary variable x whose initial value is 4, and then in the next iteration it will be 5, in the next iteration it will be 6, like that. Okay, and then what we want to check is if this x at any point of time, if this x is a multiple of 3 or not. If it is, we'll print, otherwise we'll not print. Okay, let's first write a like a flow chart how to do that. So what we want is, say for example, we'll use the same variable, say what we use, say for example x is equal to the starting number. Okay, so we'll be writing as start, and after doing this we will check the while loop condition. Actually, till what we want to go, we want to go up to 18. So we want to check if this is our while loop, this x is less than or equal to 18 or not. If it is a true condition, if the value of this expression is evaluated as true, then what we want to do is we want to execute the body of the while loop, right? Now, in the body of the while loop, what we want to do is, okay, I have to use the eraser. In the body of the while loop, what we want to do is, first, we're not going to print the number directly here. So what we are going to do is, in this body, again, we are going to check if that number x modulus 3 is equal to 0 or not. It means what? We are checking if that x, current value of x, is completely divisible by 3 or not. Okay, so if it is completely divisible, then we know that x mod 3 will give you a 0. If it is the case, then what we want to do is we want to print that number x. So if it is completely divisible, if x is completely divisible, then only we want to print the number. Otherwise, see here, we do not want to do anything, so we do not have to write any else part here. So if the number is divisible by 3, then we will print the number, otherwise we will not do anything. Okay, but no matter whether the number is divisible by 3 or not, we always want to increase the value of x by 1. So we'll be writing x is equal to x plus 1 after the if condition, right? And after execution of this line, that is x equal to x plus 1, what it will do is the control will go back to this point. And it will check the condition one more time. Now, if the condition is again true, it will come inside this body, and inside this body, again, it will first check if it is completely divisible by 3 or not. If it is, then it will print the number, otherwise it will not print the number. Now, at some point of time, see here, no matter whether this condition is true or false, you are always increasing the value of x by 1. Means every iteration is increasing the value of x by 1. And x initially started with some number like, say I wrote here x is equal to start, and here actually this 18 is end, but whatever it is, x equal to some number it has started with, say that is less than 18, then it stops. Like here, see here, since in each iteration you are increasing the value of x by 1, so at some point of time certainly this value of x will be uh, equal to or greater than, not equal to, even if it is equal to, it will be true condition. So at some point of time this value of x will be greater than 18, so at that time it will go out of the loop, right? So it means it will go out of the loop. And after that, as usual, we'll be writing here a print after loop, or the end of the program, or anything just to indicate like, okay, this is the end of the loop. Okay, now what is happening here again? Once you see here, so let me write these, instead of writing it as start, I let me write here a concrete number. Okay, and say for example here I write the number 3 or maybe 4, or let's say how the computer is going to execute this program. So initially the value of x is equal to 4 from here, and then it comes inside the loop. It first checks the condition whether x is less than 18 or not. Certainly this is a true condition. 4 is less than 18, less than or equal to 18, that is a true condition. So it comes here, and inside the body what we have done is we have written a if condition. And what is that condition is, like it will check if the current value of x, which is 4 modulus 3, is equal to 0 or not. 4 modulus 3, as we all know, that is 1. 1 is equal to 0, that is a false statement. Since this is a false statement, it is not going to execute the body of the if, that is if block. If block will not be executed. Since there is no else part, nothing is to be done. So as a result, what will happen is, in this case, like when x is equal to 4, nothing will happen at till this point. And then the control will reach this point, x is equal to x plus 1. Now see here, this statement is certainly independent of this if block. No matter whether this condition is true or false, this block, this line or this instruction is going to be executed. So as a result, x is equal to x plus 1 will be executed. And so we know, like, what does it mean? X is equal to x plus 1 means 4 plus 1 is equal to 5, that you want to store back in x. Done. And then the control reaches this point. Again, you are checking the condition whether x is less than 18 or not. So 5 is less than or equal to 18, that is a true condition. So it comes here and checking if now 5 mod 3 is equal to 0 or not. Again, it is a false condition. So if will be completely skipped, and then x equal to x plus 1. So 5 plus 1 is your 6 that you want to store back in x. And then you are again going back and checking the condition whether 6 is less than or equal to 18 or not. It is a true condition. It is coming inside the while block, and inside this while body you are again checking if the value of x modulus 3 is equal to 0 or not. This time the value of x is your 6. 6 mod 3 is equal to 0, that is a true condition. Since it is a true condition, so it will come inside this if block and it will print whatever the statements you have written inside the if block, those will be executed. So here you have written print x. It means what? In the output screen, if this is your output screen, then you are going to see print x, means it will print the value of x at this point. So x right now is your 6, so 6 will be printed on the output screen. Done. Now see, this is the end of the if block. Now as I said, now see here, this x is equal to x plus 1 is completely independent of this if block. So as a result, this time also x equal to x plus 1 will be executed. So it means what? 6 is the previous value. 6 plus 1 is your 7. 7 you want to store in the variable x. And then again you are going back and you are checking the condition whether x is less than or equal to 18 or not. 7 is less than or equal to 18. It is a true condition. So you're coming here checking if 7 mod 3 is equal to 0. No, 7 mod 3 is not equal to 0. So you are skipping this part. You are increasing the value of 7 to 8. Then you are checking whether 8 is less than 18 or not. True. 8 is divisible by 3 or not. False. So you're not printing it, and then you are increasing it, and then you are going actually to the next number, that is your 9. And then we are coming here, we're checking whether 9 is less than or 18 or not. Yes. Whether 9 is completely divisible by 3 or not. Yes. That is, then since this is also a true condition, so what you're doing is you're printing x. That is, right now the value of x is your 9, so you're printing that 9 on the screen. And then x is equal to x plus 1, so 9 will become now 10. Now after that again it will go and I'll check this condition. So now I guess if people can follow now, so what will happen is for 10 it will not print, for 11 it will not print, for 12 it will print. Okay, that is, at some point of time 11 plus 1 will be 12. It will go back, it will check it is true, it will print, it will check this condition. So 12 mod 3 is equal to 0 will be true, so as a result it will print 12, and then it will change this number to 13. So for 13 nothing will be done. Again it will become 14, no number will be printed. Then it will become 15. When it becomes 15, this condition will be true. As a result it will print a 15. And after printing 15, it will become 16. That since it is not a divisible, it will not print 16, it will become 17. 17 is not a divisible, so it will not print 17. And it will not print 17, and it will increase the value of x to 18. Okay, and then when it goes back here, it is see last number 18 is less than equal to 18. It is a true condition. It will check here if it is a multiple of 3. Yes, it is a multiple of 3, so it will print 18, and then it will increase the value of x to 19. See, when it becomes 19, this is a false statement. Like if the condition is false, if this condition is false, then only it will take this part. Now see here, in this case x mod 3 is equal to 0. If this condition is true, then it will print this number. If this condition is false, although it is a condition checking, you just do not you think that if this condition is false, it is the loop is not going to be terminated. See here, when the loop will be terminated, only when this condition becomes false. In this diagram, at least in this flowchart, at least the loop will be terminated only when this condition becomes false. If we have to write the program, then how we are going to write it in Python? So okay, let's try to write the equivalent program from this flowchart. Okay, first statement is your x is equal to 4. So what we'll be doing is we'll declare a variable x whose initial value is equal to 4. And then here we want to write this while the value of x is less than or equal to 18. This is part of the syntax, so I'm writing this column. And here, see, if it is true, what is the body? Now here we have to write the body of the while loop. So inside this body, that is, see here, we are writing this body of the while loop. This is the body of the while loop. Okay, and inside this body, what we want is we want to check if the value of x modulus 3 is equal to 0. This is part of the syntax. Now, if it is the case, then we have to leave some indent, and then here we have to write print x. But if it is not the case, else part, we are not writing anything, right? It means if it is not the case, we do not have to do anything. And after that, no matter whether this condition is true or false, we are writing, see here, the indent. We are not writing it here. If we write it x is equal to x plus 1 here, it means it is a part of the if block, but we do not want that. So what we want is we want this x equal to x plus 1 to be executed no matter whether x mod 3 is equal to 0 is true or false. Okay, now see this line, x is equal to x plus 1, x is equal to x plus 1. So this is the body of the while loop. Once this body is done, so see here, after that the control goes back here and it checks this condition. So in programming language, when you write something, when in Python, when you write your code in this way, what it will do is after execution of this x equal to x plus 1, it will now see here nothing else is there inside the in the while body. So it means what, after the execution of this body, like when the body is over, automatically the control reaches this point and it checks this condition one more time. So if your body is this much, then only this much. Okay, now when this condition is false, when this condition becomes false, your control will reach, it will go out of the while loop. Okay, and in out of the while loop means here, say you write print, this is what, of key after loop. Okay, so I am writing here, say for example, end of the program. I'm writing the program in this way. Okay, this semicolon is not necessary. I'm just writing it out of my habit. But anyhow, now see here, this is the equivalent program of this flowchart. Like see, if you know how to draw this flowchart, then certainly you know how to write the program, because this is a mechanical process. Like how do you convert this flowchart to a program? It's just a mechanical process. See here, everything, the counterpart is there. Like in this program, everything, there is a counterpart from this flowchart. See here, for example, x is equal to 4 is coming from here, x equal to 4, while x is less than, this is the way you write the while loop. I mean, this loop you are writing actually, while x is less than equal to 18, x is less than equal to 18, then you want to execute this body of the while loop. That means this is the body of the while loop. Inside this, what you want to do is you want to check if that number is completely divisible by 3 or not, and then if it is the case, then you're printing the number, otherwise, or you're not doing anything. And then at the end, no matter whether it is true or false, you want to increase the number so that you go to the next number, then the next number, then the next number. When you reach 18, up to 18, you will be following these steps. Like when you go beyond 18, like as soon as you come to know, okay, now the current value of x is beyond 18, then you do not want to continue this process. You want to go out of the loop, okay? And then whatever it is there after the loop, you want to execute a particular. So this is how the program will be executed. Now I told you how, like, the concept and how do you write the program. Now let's actually write the program and check. Equal to 4 while x is less than or equal to 18. What you want to do is you want to check if x mod 3 equal 0. See the indent here, it's automatically maintained by the Visual Studio Code. Oh, sorry, this is Colab. I'm sorry. It is automatically maintained by this Colab editor. So print x. If it is a multiple of, if x is multiple of 3, then we want to print x. Otherwise, you do not want to do anything. And after, no matter whether it is true or false, we want to execute it. We want to increase the value of x by 1. Done. And this is the end of the while. And here we want to print like end of the program. Okay, now let's see. 6, 9, 12, 15, and 18. So this program is printing all the multiples between 4 and 18 inclusive of 3. Now say for example, now say these numbers like 4, 18, and 3, these numbers are actually, these are some input to the program actually, right? Like same program. I mean, see, if somebody asks me, write a program that prints all the multiples of not 3 but 5 within the range of 4 to 18, then what we have to do is we have to change this number, not 3 by, but here we have to write a 5 here. So what we can do is we can do something like this. We can like use some variables to represent those inputs. Okay, so for example, say we want to find the key that for what number we want to print the multiples. Okay, that number we call as, say for example, key number. So in this case, or in this example, key number is 3. Then what is the starting? Say in this case the starting is 4. And what is the end? In this case the end is 18. So what we want to do is we want to print. Now see, initially we want this x to 4. I mean, in that specific example it was x equal to 4, but in general it is whatever it is, the start, right? Now if x is not less than equal to 18 here, if x is less than equal to end in general. Now here it is x mod 3 is equal to 0. So here that 3 is actually what? That the key number. If x mod key number is equal to 0, you want to print x, otherwise you want to increase the value, right? Now this program should give you exactly the same output. That is, if I re-execute this program, this output should not change. See, 6, 9, 12, 15, and 18. But however, the advantage of writing the program in this way is, see here, I can check now any number. Like if I want to check all the multiples, if I want to print all the multiples between 5, or all the multiples of 5 between 4 and 18, I just have to change what is the key number. Key number is now 5. Execute it, It'll print you all the multiples of 5 within the range of 4 and 18. Suppose we want to change the range. Now, no, it's not 4 and 18. Say, for example, it's 40 and say some, some number like 1, 8, say 0, 8, 9, something. Okay. And in this case, we want to print all the multiples of not say 5. I'm just writing say 553, say. Okay. And then print. So it is printing. See here, if you take any number that is a multiple of 553, say for example 6083, it should be a multiple of 553. I hope people have understood this program. Now let's go to the next one then. The second program. It says write a program to print the multiplication table of 5. Before writing the program, first let's see what we want as the output of the program. That is, we want to print the program says write a program to print the multiplication table of the number 5. So it says that. Now the thing is, what is the output that we are expecting from the program? Okay, let's first make it clear. So what we want is we want to write a program that generates this output on the screen. Now if you see the output, we want to print. Basically, we want to execute the print statement, something like this. That is, we want to print. See here, in each and every line here in the output, the 10 lines there. So in each and every line of the output, what we want is, see here, the first part, you see 5 into 5 into 5 into. This part is there everywhere in all the 10 lines, right? So what we can say is, okay, in the print statement, we want to print 5 into as it is. So we can say like, okay, if we want to print something as it is, then we can print it in the form of a string. And for that reason, what we can do is we can write that 5 into within double quotation. It means we want to print this 5 into as it is on the screen. Okay. And after printing 5 into, what we want in the string is a number. Actually, see here, now in each and every line, this number is not same. See here, in the first line 5 into is there, second line also 5 into, third line also 5 into is there. But in the first line here it is 1, then in the second line it is 2, in the third line it is 3, and in the last line it is 10, right? So what we want is here, we cannot write the number directly here. I cannot write 5 into 1 because in each and every line that number is changing. So we can say, okay, here after printing 5 into, what we want is we want to concatenate the number I with this string, okay, with this prefix. But the thing is, again, in Python, you know that like you cannot concatenate a number with a string. So if you want to do that, one thing that you can do is you can convert that number to a string, and that is the easiest way. So what you do is you can write here the string function, and you pass that the number I to the string function. So what it will do is it will convert that number I to a corresponding string representation. Okay, so ultimately, and this plus symbol will concatenate, that is, it will append that string representation of the number with this prefix 5x. Okay, so more or less now we can see that, okay, now if we can change the value, if we change the value of I, say for example, you just consider the value of I right now is 1. So what it will look like, 5 into 1. Then if the value of I is 10, it will look like 5 into 10. So here, this part. Okay, this part is done. Then after printing this part, what we want is, see here again, in each and every line, this equal symbol is coming as it is. So we want to print that equal symbol as it is. So what we want is, that is, after this, again we will concatenate the string where the only character of the string is this equal symbol within this double quotation. If we write, it means like that is a string that contains only one character, and that character is this equal symbol. Okay, now, and after that, what we want is, after this equal symbol, again, you see, after the equal symbol, a number is getting printed in each and every line. However, that number is not the same number, right? I mean, 5 in the first line, 10 in the second line, 15 in the third line. But if you think for a moment, then you will feel that, okay, that number which is there on the right hand side, that actually depends on the variable I that you used on the left hand side of this equal symbol, right? These I. So here, if it is the first line, it means it is 5 into that particular number. In the second line, the value of I is 2. You want the value of I to be 2. And on the right hand side, you want to print 5 into 2. So here what we can do is we want to print here, that is, we want to append here the result of the multiplication of 5 with the current value of I. And you know that this 5 into I is a number. This part is a number. And if you want to concatenate, that 5 into I, the value of 5 into I, the result of 5 into I with this string, then what you have to do is you have to convert the number, that is 5 into I, whatever that number is, that number you want to convert to a string representation, just by passing that number to this string function. So what it will do is, say in the first line, it will be now 5 into 1 is your 5. You are passing it to the string representation. I mean, you are converting it to a string. So the string 5 will be concatenated with this part, right? And that is the end of the print statement. So from the expected output, this is our expected output from the program. From the expected output, what we derived that we want to execute this print statement. That is, our problem will be solved if somehow we can execute this print statement for different values of I. So for example, if you execute this print statement for I is equal to 1, then you know what will be the output, like 5 into 1 equal to 5. It will print exactly the first line. Then if you execute this print statement with I equal to 10, then it will print exactly this last line, right? So we want to execute this print statement again and again as long as the value of I is less than 10. So you know how to do that using a while loop. Let's see. What will you do is you will write a while loop and you will check if the value of the variable I is less than or equal to 10. If it is the case, then you want to print this line, and also you want to increase the value of I by 1. And again, you see, before getting into the while loop, you have to make sure that the value of I is equal to 1, because we want to start the value of I from 1. So when the program gets executed, what it will do is it will initialize the value of the variable I to 1 here, and then it will check if the value of the variable I is less than 10 or not. Since it is a true condition, so what it will do is it will print this 5 into 1 equal to 5. And after printing this line, it will go to the next instruction, which is I equal to I plus 1. So it will change the value of I from 1 to 2. And then it will go back and it will execute this I less than 10, less than or equal to 10 condition one more time. Since the condition is again true, so it will print the next line, 5 into 2 equal to 10. Then in that way, it will, in each step, you are increasing the value of I by 1. So at some point of time, the value of I will become 10. And that time it will print this last line, 5 into 10 is equal to 50. After printing that line, 5 into 10 is equal to 50, it will change the value of I from 10 to 11. See here, 10 plus 1 is 11. That will be stored as the new value of the variable I. And after changing this value from 10 to 11, the control will again go back and it will check this condition, whether the value of I is still less than or equal to 10 or not. So 11 is less than or equal to 10. That time it will be a false condition. So the control will go out of the loop. So as a result, on the screen, you will be able to see these lines as output. Now let's write the program in Google Colab and check our understanding. So for example, we declare a variable, say I is equal to 1. And then what we want, that semicolon is not needed. Okay. And then what we want is, as long as the value of the variable I is less than or equal to 10, what we want to do is, we want to print, see here, we want to print, the first part is your 5 into. So these I have written as 5, the asterisk symbol. But if you want, certainly you can write 5x. No problem with that. Because anyhow, anything you write within this double quotation, that will be considered as a string. And it will not be interpreted actually, what you have written there. Okay. So I'll stick with this 5 asterisk, but you can certainly write 5x, no problem. Then 5 into, then here what we want to do is we want to concatenate after 5 into, what we want is we want to display or we want to concatenate the value of the variable I. Directly you cannot write I in this way because that I is a number, whereas this 5 into is a string. And if we want to concatenate, then what we have to do is we have to convert that number to a string first by using this str function. And after converting, then we can concatenate. So it is now 5 into whatever the value of I, and then again we want to concatenate with this equal symbol is equal to, then again we want to concatenate. Here again we want to concatenate a number. And what is that number? That number is whatever it is the result of 5 into I, this part, this number. But the thing is, again, that is a number, and if you want to concatenate it with a string prefix, then what you have to do is you have to convert that number to a string using this str function. So done. Now, after doing this, after executing, that is, after displaying the first line, after displaying or after executing this print statement, every time what we want to do is we have to make sure that we go to the next number. I mean, 5 into, after displaying, say, 5 into 1 equal to 5, we have to make sure that now in the next iteration, it should print 5 into 2 equal to 10. It means that we want to change the value of I by 1 every time we print a line. So what we want to do is we want to write I is equal to I plus 1. Done. And that's all. At some point of time, the value of I will become 11. 11 is less than or equal to 10. It will be false condition, so it will go out of the loop. So just to make sure that it goes out of the loop and the program ends, here we'll be writing print, say, out of the loop. Okay. Let's execute this program and check the output. See, as expected, you are getting 5 into 1 is equal to 5, then 10, then now, as expected, whatever the output we were expecting, exactly the same output we got, right? Now see here, if you want to give some space here, then certainly you can give 5 into, then, before this equal symbol, after this equal symbol. So, like that. Okay. Now see, if we look at this program, every time we execute this program, what it will do is it will give us the multiplication table of a very of a specific number, like always it is the 5, it is the number 5. But if you think for a moment, printing the logic of printing the multiplication table of 5 is not very different from the logic of printing the multiplication table of, say, 3 or say any other number, say 13, right? So to make this program, a general program, right now the program is very specific. What we have done here is we have hard-coded this number 5. Here, we have hard-coded this number 5 here in this program. But in general, like whenever you are writing a program, you want your program to be more general, right? And we can certainly see that actually, right? The same logic we have to write, or the same program we have to write if you want to print the multiplication table of 3, isn't it? Yeah, one person might say, okay, if you want to print the multiplication of table of 3, certainly you can change this 5 from 5 to 3. And here also we have to change this value from 5 to 3. Yeah, that will do the work. It will print now the multiplication table of 3. And that is what, like, okay, we can achieve this thing by changing the program a bit. But let's see, is there a better way of writing the program so that whatever the changes that we have to do in the program is minimal? Yeah, fortunately, there is a way. I mean, what is the way? A standard way of doing it is, instead of hard coding this number 3, the way I have written it here, what we can do is we can make use of a variable. Let's say this number for which we want to print the multiplication table, let's say call that number, say, the key number. Okay, this is a variable name, and you can call this variable anything actually. You can call it as an X or anything. But here in this program, I'm just calling it key number. Okay, so key number is equal to, say, for example, 3. And here in this place, now it is not 3 actually. It is whatever the value of this variable key number. So now how do we print that the value of the variable key number here? Well, okay, first convert that key number to a string, and then you concatenate that string representation of key number with the rest of the string, right? So this thing into I as it is, and here again, see here, it is not 3. It is the key number multiplied by I. Whatever the result, you want to convert that result to a string, and you want to append that string version of the result with the rest of the string. And if I execute the program, you should see the same output here. Yeah. But the advantage of writing the program in this way is that now if you want the multiplication table of say 13, you just have to change the value of this key number. I mean, change the value of key number to 13 and click play button. It will display you the multiplication table of 13. I hope you people understood this program. Now let's see the third program. What this program is asking you to do is print all characters of a string separately. We know in Python a string is a collection of individual characters, right? So when you write s is equal to HELLO in this way, we know that in the RAM there will be a container. I mean, there will be some space where this string hello will be stored. Right, and this container has the name s. And also we know that each cell will be given a number, and that starts with the 0, and we know that this number is called as the index of the cell. So for example, the first cell will have the index number 0, second one will have the index number 1, third one will have the index number 2, then 3, and the last one will have the index number 4. Since the index number starts with 0, the last index, that is the index of the last cell, will always be 1 less than the total length of the string. And also we know, like, what is the length of the string? It is the number of characters present in a string. So up to this point, we all agree, right? I mean, a string is a collection of some characters, and again, in the memory, a string is actually considered as a collection of some cells, where each cells are given some numbers, and those numbers are called as the index number of that particular of those cells. Now, let's see what is the use of these index numbers. I mean, see, as soon as you see these index numbers, an intuitive idea comes into our mind, like, okay, these numbers are useful to actually, uh, if we want to specifically access a particular cell or a particular character, or if we want to know, like, what is the character there in cell number 2, what is the character there in cell number 4, right? So with the help of these index numbers, what we can do is we can actually access the content in a particular cell. Say, for example, in Python, s is a string, and if you want to know what is the content of the string s, that time you certainly do not have to go through each and every character present in the string. Directly, what you can do is you can write some statement like print, and you want to print this string s. Okay, that is okay. That is like one situation where you can treat this string as a single entity. However, in this program, what it is asking you is like you have to print each and every character present there in the string independently, means separately. So in that case, what the program is basically asking you to do is it is asking you to iterate over each and every character present there in the string and print them. Now see, suppose for example, I want to print the character which is there in cell number 0. So in Python, if you want to do this, you know like how to do it. Like you can write print. I want to print in the string s, whatever it is there in cell number 0, I want to print that particular character. That's fine. Now again, if you want to print, say, the character present there in cell number 1, so what you do is you can write print character present in cell number 1. And similarly, if you write these 5 print statements in the program, it will certainly print you all the characters present in the string s, right? Now, if you change the content of s, then certainly again you have to change this print statement. So that should give you an idea. Like certainly, although it is doing the task for this given string s is equal to hello, it is not a general solution. There should be a better way. If you think for a moment, if you look at this solution, this bad solution for the time being, you see that what you're doing is you're basically executing the same print statement. That is, you are executing the same print statement as within this square bracket. What you're writing is you're writing a number, right? And that number I changes from 0 to whatever the length of the string minus 1. So in this case, length of the string is 5. 5 minus 1 is your 4. So in this specific case, this I value changes from 0 to 4, right? So it means what? For the first time, like to get, to print the first character, what you do is you print s of 0. To print the second character, you print s of 1. Then you print s of 2, s of 3, and s of 4, right? So like you should now think, okay, now I guess I'll be able to do the thing. I mean, I guess I'll be able to write the program, because it's like, okay, here's the place where I can use a while loop, and I can I can change the value of I from 0 to whatever the length of the string minus 1, and then inside that while loop I can put this print statement. Yeah, that's 100% true. I mean, that is 100% right. That is how we are going to iterate over all the characters present in this present in a given string. Let's see what I mean is, say, what you have to do is you have to write like, okay, I want to start with the initial value 0, and then what I want to do is I want to write a loop like while as long as the value of, sorry, you do not have to write a bracket, as long as the value of I is less than, you know, whatever the length of the string is. So for example, I'm writing here a variable, as long as the value of I is less than the value of the variable L, what we will do is we will print the character present in the ith index of the string. And after printing the character, what we want to do is we want to move to the next character. That is, we want to increase the value of I by 1. And after doing this, again we want our program to go back to this point and reevaluate this condition one more time. And again, if the condition turns out to be true, we want this block of code to be executed, and again we want to repeat the process. When the condition becomes false, that is, if the value of I is less than L, like, I have not said like what will be the value of L, but anyhow, if the value of I is less than this given number or this specific number, then what we want to do, if the value of I is not less than this specific number, it means that condition will become false, and that time we want to go out of the loop. And just to make sure that like we are out of the loop here, we are printing one line here, say for example print, say out of the loop, out of the loop. Now let's the final nail here. The point is like, what is this L? We know like that I should be less than L. This L should be the length of the string, right? So what you can do is, how to find the length of a string. You have to make use of the length function. So L is equal to length of the string S, whatever that string contains. Like that string, if it is hello, then L will be 5. If it is something else, then based on that, L will take its value, right? So ultimately, this will be your program, and this is the program that you will write, and you have to write to get to print all the characters present in a given string. Now let's see. Let's write the code in Google Colab and check our understanding. We have a string S, and there we are storing, a string. Say for example, hello, HELLO. Then what we want is, first thing, we want to find what is the length of the string. So L is equal to length of the given string S. And then we want like the counter, actually the pointer that will that will move over that each and every cell. So initially we want that counter to have the value 0. So initial value of I is equal to 0. Now what we want to do is we want to check if the value of the counter I is less than L. As long as the value of the counter I is less than L, we want to print the character present in that particular cell or in that particular index. It means what? We want to print the character in the string S at that particular position I. Okay, and after printing the character at that particular position I, we want to increase the value of I by 1, so that we move to the, in the next iteration, we move to the next character, right? That is, we want to increase the value of I by 1 every time we print a character. Okay, and that's all. And after one, like see here, since we are increasing the value of I by 1 every time this loop is getting executed, so at some point of time you can expect that the value of I will, that is the value of I will be equal to the length of the string. So that time this condition will become a false condition. So, and that time the controller will go out of the loop. Now it means what? The controller will reach this point. Now here, just to make sure that like we are out of the loop and the program terminates here, so we can write here a statement like print, say, out of the loop. Okay, let's execute this program and check the output. See, it's printing all the characters present there in the string separately. Now see here, if you want to now this string, if you change the value of this string, then automatically the same program will print the characters present in that string separately. So for example, what I mean is, if I want to now, instead of hello, if I store, say, another string, say for example a fox and a dog, say, and I just have written some out of the blue, something came into my mind and I wrote it like that. So now suppose this is the string, and then if I execute the program, I'll be able to see that all the characters are printed separately, and even this space is considered as a separate character, and it is also printed in a separate line. I hope people have understood now how how to write these three programs. Now, see, it's not only about these three programs. I mean, if you know how to write these three programs, then certainly you know how to write any program that now falls into the pattern of these programs. Basically, all these three programs, what they are demonstrating is that sometimes we have to repeatedly execute a set of instructions again and again based on some condition. So that is where we have to use a loop. And these three program X will demonstrate, okay, how you can make use of a loop to solve such or to write such programs. Okay, guys, then let's see you in the next session.